This is the Trig Quiz 1 morning review. Number 1, state the period and amplitude of the function. So the rule for define the period of sine or cosine function is simply going to be the period of the original function divided by the absolute value of b. So the b value is just the coefficient in front of the x inside the sine function. So it's just 2 pi over absolute value of b, 2 pi over 3 over b. And then if we multiply by the reciprocal, is 2 pi times pi over 3, which is 2 pi squared over 3. Amplitude is just the coefficient in front of the sine graph, which is the absolute value of the coefficient, so just 4. All right, number 2, solve the equation. So if we want to solve the equation with a double angle, we can convert this into something that will be helpful. So it looks like we want to choose the one that'll be the most helpful. So we already have a sine function. So if we expand the cosine 2 theta using the one with sine, so cosine 2 theta can be represented as 1 minus 2 sine squared of theta. So replace cosine 2 theta with this expression, and then rewrite and then bring down the minus 1. Now we can go through factoring, so bring everything over to one side. The ones cancel out. We're just left with 2 sine squared theta plus sine theta. Factor out the sine theta. We're left with 2 sine theta plus 1. So sine theta equals 0, and 2 sine theta plus 1 equals 0. So theta is equal to 2 pi. Okay, so because we want theta that's between 0 and 2 pi, 0 not included, only 2 pi included. And then sine is negative 1/2 in the third and fourth quadrant, so 7 pi over 6 and 11 pi over 6. All right, before we get down to 3 through 6, let me just review steps to evaluate limits. First thing we always do, if we're trying to evaluate limits algebraically, we take the x value and we just plug that in. All right, if we plug that x value in, and if we get a real number, then that's the answer, that's our limit. There's no need to do any further work. If we plug in the x value, if we get a non-zero over a 0, let's say 6 over 0 or 10 over 0, then that means the limit is undefined. Limit does not exist, and that's the end of the answer. If we get 0 over 0, okay, meaning no, right? If we get 0 over 0, then that tells us that this is an indeterminate form, that we can keep going with this problem, that if we simplify and reduce, we should be able to work our way down to a real answer, a limit. But either way, 0 over 0, well, sometimes we may get undefined still, but if you get 0 over 0, that tells us that we have to keep going. And if you get a 0 over a non-zero, let's say 0 over 6 or 0 over 9, then that's a real number. That's still going to be 0. All right, let's look at number 3 here. Limit of tangent of pi x over 3 as x approaches 2. So first thing we do is we plug 2 in for the x. So tangent of 2 pi over 3 is simply negative root 3. And that's a real number, so no need to go any further. That's our answer. Okay, number 4, sine of 4x over 9 as x approaches 0. Plug 0 in for x. So we get sine of 4 times 0, which is sine of 0. Sine of 0 is 0. 0 over 9 is a real number. That's 0. Okay. Number 5. All right, so first thing we do is we can plug in 0. So tangent of 0 minus sine of 0 is 0. Sine of 0 cubed is still 0. So 0 over 0 tells us that we can keep working with this problem. One thing that we can do is to try to simplify and cancel out is we can convert everything to be in terms of sine and cosine. So tangent I replace with sine over cosine. So once we do that, we can also find a common denominator. So I can convert the sine of x to be sine of x cosine x over cosine x. Okay. Combine the numerators together, and I get sine of x times 1 minus cosine x over cosine of x, and then I can flip the sine squared, sine cubed up to the top to share the same denominator space. And then from here, I will be able to cancel out one of the sine x's, and we're left with 1 minus cosine x all over cosine x times parentheses 1 minus cosine squared x. 1 minus cosine squared x can be replaced or can be factored to be 1 minus cosine x, 1 plus cosine x. We cancel out one of those, and then we're left with 1 over cosine x times 1 plus cosine x. We've factored out a term, so or reduced a term, so we should be able to reevaluate the limit, see if we get a real number from there. So 0 plugs into the denominator, so cosine of 0 is 1, cosine of 0 is 1, so 1 plus 1 is 2, so 1/2. Number 6, if we plug in 0 into the expression, we get 0 over 0, so that tells us that we can keep working with the problem. Okay, so from here, we can find convert everything to be sine and cosine. So I'm going to rewrite this as x over sine x plus 1 all over x sine of x. Notice that I can't cancel these terms out because x over sine x is attached to the plus 1. There's a plus sign here. So we have to, what we can do is maybe undo this complex fraction by trying to get rid of this denominator. So if I multiply everything through by sine of x, the term that's causing the complex fraction, then I should be able to undo and cancel out that sine of x. So if I distribute the sine x through each term, sine x with this sine x will cancel out to be just x. 1 times sine x is sine x. Sine x times x over sine x. The sine x cancels out. We're left with x. So x plus sine x over x. We can rewrite this as two fractions. So x over x plus sine of x over x. X over x is 1. Sine of x over x, we know we have a special rule for that. Limit as x approaches 0 for sine of ax over bx is simply just going to be the coefficient. So that's equal to 1. So 1 plus 1 is equal to 2. Okay, number 7, limit of sine of cube 2x over 12x cubed. I'm going to split this up into individual terms. So sine of 2x, I'm going to rewrite it as sine of 2x, sine of 2x, sine of 2x. There's 3 of them. And then the 12x cubed, I can pull 1 over 12 out in front and then assign x's to each of the fractions. And the reason why I want to do that is because I'm going to try and use the special property, the special trig property. Limit as x approaches 0 for sine of ax over bx is simply equal to a over b. So we know this expression is 2 over 1, that's 2 over 1, that's 2 over 1 times 1/12. So 8 over 12 gives us 2/3. Oh, and then I forget the fact that the first thing we do is we always plug in. And if we plug in, we get 0 over 0, and then that tells us that we have to keep working with this problem to simplify. Okay, number 8. If we plug in pi over 2, we get 0 over 0, so we can keep working with this problem. Convert everything to be in terms of sine and cosine, so cotangent becomes cosine over sine. Cosecant is 1 over sine. If I flip that to the top, I get the sines to cancel out to be just cosine of x, and then the limit of cosine of x as x approaches pi over 2. Plug pi over 2 in for x, cosine of pi over 2 is just 0. Okay, last one here. Limit as x approaches 0 for 1 minus cosine x squared over 3x cubed. Plug 0 in for the x's. We get 0 over 0. So we can tell us that we keep working with this problem. 1 minus cosine x is 1 minus cosine x times 1 minus cosine x. I can split the 3x cubed to be x times 3x. And then we know this expression will go to 0 using the special property that involves the trig property. We know this goes to 0, so that's 0 and 0, but this is 1 over 3 times 0. That's 1 over 0, so there's no way 1 over 0 can ever be defined. So even though we got 0 over 0 to begin with, if we try to clean this up a little bit further, we're still unable to resolve this, so this will be undefined, does not exist.